students. So now we're going to pick up with the 2.5 continuity problems where you have the practice. So I'm going to send you this short video tonight so you can finish out the lesson. So we're going to discuss the continuity of the function by using the three-part definition for continuity. And if you see, I've copied the three-part definition where f of a is defined, the limit as x approaches a exists, and the limit is equal to the function value at that point. So in the first example, we're dealing with what appears to be infinite discontinuity. So we would look at the first criteria at x is equal to 3, and then we would say, well, f of 3, if we look at it, and it's the only place on the graph at x equal to 3 that requires any type of discussion, because we know on the other two branches of the hyperbola, both branches are defined everywhere else. So f of 3 does not exist, so we can say that the first criteria fails. And then the second criteria, the limit, as though we know that it's not continuous based on the fact that if one criteria fails, then it's not continuous at that point. So the second criteria is the limit as x approaches f of x. That also does not exist because you're going from positive, or you're going to positive infinity as you approach on the right and negative infinity as you approach on the left. So the third criteria simply does not exist. So in the first discussion, we've got this information on continuity. So the three-part criteria is that the first part fails, the second part fails, and it just fails all the way around. So moving on to the second problem, and you can see clearly it has infinite discontinuity. So with infinite discontinuity, that's the situation you're going to have. Fail, fail, fail. Okay, so now if we look at the next one, I've already factored the expression for you. We're going to discuss the continuity of the function by using the three-part definition. So I have two places in this, because even though we remove the discontinuity of the x minus 2, it still exists, and we have a hole as the limit. If we look at the limit and plug in x is equal to, for instance, here, let's plug it in here, x is equal to 2 here, we get 1 over 2 plus 4. You can clearly see that it's equal to 1/6. So if we take a look at the discontinuity at x is equal to negative 4, we see that we have infinite discontinuity, and we have the following. F of negative 4 does not exist. And this is kind of the situation that we have for the first one. This is exactly the limit as x approaches negative 4 of f of x does not exist. So because it's infinity and negative infinity, it just doesn't exist. And then we have the third part criteria where they can't be equal to each other because these 1 and 2 don't exist. So then at x is equal to 2, we have the first criteria, f of 2, does not exist. So already we know we don't have continuity, so we have a fail on that one. And then we have the limit as x approaches 2 of f of x is equal to 1/6, but then the third one fails because f of 2 is not equal to the limit as x approaches 2 of f of x. So we have 2 failures and 1 pass, but still this is the situation that we often have for point discontinuity. And then we can have point discontinuity, and we can have another point. Say there was a point down here, as long as f of 2 was defined, but in this case it's not. F of 2 could exist. The first two could exist, and then still the limit is not equal to the function value. So let's see what we have down here. With break discontinuity, here, everybody get that? Okay, if not, then you can stop it, pause it, and then go back to it. So, and I guess we should say the type of discontinuity with the graph, that this is point discontinuity. And stop rolling. Okay, point discontinuity. Okay, so, and then the last one we want to look at is looking at the three-part criteria for a break in the graph where it's jump discontinuity. And clearly you can see the jump discontinuity. So at x is equal to 1 is where we appear to have the break in the graph. So we're going to look at f of 1. We're going to look at f of 1 as it looks like we get 5. We plug it into the bottom part of the graph, or the bottom part of the piecewise function, actually, top part of the graph. So then we want to look at the limit as x approaches 1 of f of x. And that appears to not exist because the limit from the left of f of x is equal to 1, and the limit from the right, sorry, here, messed up the notation here. So the limit as x approaches 1 from the left and 1 from the right of f of x, there we go, is equal to 5. So the limit does not exist there. And therefore, the last one, f of 1, is not equal to the limit as x approaches 1 of f of x. So we have a fail, and here we have a fail, and here we have a pass. So that's the situation you'll have with jump discontinuity. Well, that's about all. There are the limit laws that you see on the next page of your notes, and I'll just go over those quickly with you. Okay, this is actually 2.5. So if you're looking at the limit, actually it was 2.3 and 2.5 where you use these. Make sure that you know these. The limit of a constant is a constant. The limit of just x is just a substitution. The limit of a constant times a function is that constant times the limit. So you're able to pull this limit out front. Pull the constant out front. And then the next limit law, I think I illustrated that today, was the limit of a sum is equal to the sum of the limits. So the limit of a sum is equal to the sum of the limits. And the limit of a difference is equal to the difference of the limits. And the limit of a product, so the limit of a product is equal to the product of the limits. You can kind of see that's multiplied together. And then when you have a power, a limit of a function to a power, you can actually this one should read differently. It should be f of x to the nth power is equal to, so you see, this is very convenient. Sometimes you can take the limit of f of x and then raise it to the power. Okay, so that's all I have for you. I'm going to send this to you, and I have a few more examples on the homework that you could work on, but we'll touch base tomorrow, and I will see you soon. Bye.